Okay, good evening, everyone. So now let me start with the next chapter, which is on kinematics. So this is a problem which I think most of the students in my classes, wherever I have taught, had made a mistake. Let us read this problem to understand what it is about. A vertical circular disc has different grooves. You see, these are some small slots like things along various chords. Particles are released from the upper end O. So you are releasing the particle from here. Then the time taken by the particle to reach the ends of the groove OA, OB, and OZ respectively. What is the time taken by OA? If I release a marble from here, it takes some time. Let me say this is your TA. Time taken by TA. Time taken by this one is TB. And time taken by this is TC. Now the question is, relate the times. So definitely by looking at a glance, what is there to solve in this here? Quite easier, no? See, this path length is much larger. All of them will experience an acceleration due to gravity. So definitely they should fall down faster, right? Very clear. That's what we see. So therefore, we think that, okay, this will be falling faster and this will be a bit slower. This will be least and this will be a bit slower. That's what we think. Okay, in other words, it's something like if this is TB, I can say TA will take a long time and then TC will take TA will take a long time. Sorry, this is the shortest path. I'm sorry. Yes. This is the shortest path. So I can now say the marble will reach the point A quickly. Okay. And this will take a longer time because length is larger. So TB will be the longest time. Next comes TC because the next longest time. Then comes the TA. This should be your answer. Option B should be your right answer. That's what most of them think. But definitely this answer is incorrect. Okay. So what we need to learn from this problem is that physics problems are not tougher, but you make it complex and tougher by assuming some things. Do not assume. Until and unless you don't get a confirmation, never assume. Very, very important. Okay. Every physics numerical, there would be a strategy to work it out. You need to look at it. Never assume, never presume, never imagine that this is what can happen. Now you see, I have imagined here. So therefore, that's what I have assumed this. But this is incorrect. Let me show you why it is incorrect. Right? Okay. Now what we'll do is let us look at the working. Now we know, so this is a circle. Now if I join this line AB, what do you think this angle OAB will be? Angle OAB would be what? Any idea? Look at this. This is a triangle inside a half circle. What do you call half circle as? Semicircle. What is the angle in a semicircle? What's the angle? 90 degrees, right? We already learned this in geometry. So this angle should be 90, simple. In a similar way, if I join this also, this angle should also be equal to 90, right? Now, this is a clue that has been given to you. Because what you need to ask is, why inside a circle? In the whole problem, you have put some grooves over here. Why inside the circle? Instead of the circle, if I remove this circle, I could have given A, B, C itself, right? Okay, this is a question we need to look at. Okay, so he did not give you A, B, C, but instead he has given you something like a big circle where A, B, C are the points on a circle. And then he is asking. That means the circle is giving you some clue. And that's what you need to realize here. Okay. Now, if this is 90 degree, now this is a OAB is a 90 degree triangle, right angle triangle. Now, towards it, what is OB? OB is nothing but the diameter, which is nothing but 2 times radius. Or if you want, I can keep this as D itself. I don't want to keep 2R. Let me keep it as D, where D stands for diameter. Okay. Now, from the triangle, what is OA? OA divided by OB is equal to OA by OB equal to what? Adjacent by hypotenuse, which should be cos 60. This implies OA should be equal to OB cos 60. What is OB? D, which should be D divided by 2. Cos 60 is half. So I got this one. In a similar way, take some space here. But I'll keep it over here. Yeah. In a similar way, if I take OC, I'll write it here. OC divided by OB is equal to cos 30. Am I right? Adjacent divided by hypotenuse. Cos 30 or OC should be equal to OB. What is OB? D. Cos 30 is root 3 by 2. Now we have got this. Now why are we doing all this? That's the question we have. That will be evident further. Now what do I need? Now you see this is an inclined plane. This is also an inclined. In one of the videos, I have already shown you how to calculate the time taken for an inclined plane, right? Let us use that approach. Now towards it, starts from O, reaches the point here. Now we know what is this length over here, which is nothing but D by 2. OA is nothing but D by 2. So we can always use S equal to UT plus half AT square. So D by 2 is equal to U, starting from rest, right? 0 plus half. What is G? See, if it goes down vertically, it is G. But if it takes an angle like this, I can resolve this G into the horizontal and vertical. So the component of this along this direction would be G cos 60. G cos 60, right? Just a minute. Okay, I'm back. Okay, somebody at the door, so I was not able to look into it. Okay, so this is 0 plus half into, where is my cursor? It's half into, what is the acceleration due to gravity here? It is not G, it is G cos 60. G cos 60 into T, and what is this? This is TOA, or we call this as TA square. TA square, right? Y square once again, see? And now what happens here? This should now be equal to half G into half into TA square. Now what will this become? This D by 2, this 2 goes away. Thus I am left out with D is equal to half G TA square. Okay, so we have got D equal to half G TA square. We have got this one. Now what is this now? We have just taken one of these parts and set up an equation by considering the time over here. For the first marble we have done, which is flowing along the point OA. Now along OB, if you find what is the distance here, once again D. Okay, this is for which path? OA. For path OA. The second path. Now which path I am looking at? OB. OB may. Now D is equal to UT plus half AT square once again. What is U? 0 plus half into, what is G? G is G only, because you see it is falling vertically downwards, no angle anywhere. So it is G into T. What is B here? TB square. TB square. Yeah, look at this. D is equal to half GTA square. And the same answer I'm getting here. Half GTB square. Good. Okay. So we have got the same answer. From here, what do we infer? We can infer from here that TA is equal to TB. But don't jump to conclusions. Just wait. Okay. That means the time taken by the marble to start from here and to reach here is the same time taken by the marble to start from here and to reach here. Curious, right? Amazing. Physics cannot tell lies. You need to work it out to understand it. Now what is left? This OC is left. Okay. Now along OC, let me write here because I don't have space. OC. Now along OC, what is the length of OC? D root 3 by 2. So I will write d root 3 by 2 is equal to ut plus half g. What is g here? G cos 30. G cos 30 into tc square. Now what do I have here? I can now write this as half g cos 30 is what? Root 3 by 2 into tc square. Now once again, what happens? This root 3 by 2 and this root 3 by 2 gets over. Or in other words, now I get, what do I get? D is equal to half g tc square. See, I got d equal to half g of gta square, half gtb square, half gtc square. Now what is your inference? What is your inference? The inference is that TA is equal to TB is equal to TC. So this is not your correct answer. This should be your correct answer, right? To whomever had given this problem, everyone made the same mistake. Okay. So this problem is supposed to make a mistake. The reason is because you should work it out. Until unless you work it out. See, most of the students commit this mistake by having a blind intuition, thinking that this might be correct because of this. You become a bit lazy about it. Try working it out. If you try working it out, you will get the correct answer. Okay. So let me stop here. Thank you, friends, for watching this video. Let me continue with some more kinematic problems in the next class. Thank you. Like, share, comment, and subscribe so that you appreciate my teaching. And I will also be, I'll take more interest to look for such problems and try to solve it out. Thank you.